Hey guys, Jason at JacFab here. It's Saturday. Got a bunch of stuff to do. I got some top secret government related stuff going on in the ADX. Yeah, I can't even show you. Top secret. Government. But it's got a drill, just like our intake manifold spacer. So again, I apologize for the drill noise. I've got about 45 minutes to kill. So I figured let's fire up the laser, let's cut some foam for the LaminatorFX shipping boxes. So we'll get some foam up in here. I'll show you what we're gonna cut on the computer. And I've got to cut 2 or 3 sheets of this, probably 3 sheets. So we'll get some different angles and stuff. Talk about the laser a little bit. Maybe you guys will learn something if you're into lasering. And yeah, I'm also working on a part for an ATS-V. So as soon as we get done playing with the laser, we'll talk about the ATS-V a little bit. Okay, we've got our foam in the machine here. We got some magnets kind of holding it down. Once we hit go and the head of the laser gets down around here somewhere, I'll put a flat bar across this to flatten this out. This stuff's not super flat, but we need it to be flat when it engraves the logo. Otherwise it's going to look real bad. And then once the logo's done, I can pull the weight off, and then nothing else is overly critical. So here on the computer, this is Lightburn, better software for laser cutters. You can see here what we're going to do. So we're going to start with the logos in the bottom, and then we're going to proceed to cutting all the ID holes here in yellow, and then we're going to cut across and then down, and then finally we'll do a perimeter. This is called common cutting, where basically everything is edge to edge. It saves you some time, and I always forget that this is a touch screen. But anyway, so you can kind of see here that this row of the logo is in red, and then this far row is in 2 different colors. That's because it's running at the same speed, but we'll have to change the power on this corner of the laser to get the logo to look good. And that's because this thing runs off like smoke and mirrors, right? So back there at this hole, the laser comes out, bounces off a mirror, bounces off this mirror, bounces off this mirror, through the focus lens, and then finally to its destination. So the farther away you get from this corner, the weaker the laser is. So what I found is at the speed that I'm trying to engrave at, which is 500 millimeters per second, to about here, the logo's good. But on this section here, the power needed to be raised to get a consistent look between sides and maintain that same fast speed. So anyway, you won't see really any change as far as that goes once I start running this. But anyway, so we'll set the camera down inside the machine at first, and we'll let her run and enjoy. All right, here we go. And you'll see me pause this in just a second, and I'll put a big bar across here to get this flat while we do the logo. So right there, we're going to pause. Set the bar on. Reset the focus height. And then we'll let the logo run. these into a garbage bag. Pick up all the straps. So now we'll get to about like so, and we'll hit the frame button, and that's going to go around the outside perimeter and tell us if we're on the sheet or not. Oh, we're off the corner there. All right, well, that tells me I need to scoot this around a little bit. Move that. Try her again. Okay, so I'm going to resend this file with my changes. I noticed that the perimeter line, I didn't have the air assist on. I don't know if it showed it or not, but it started to smoke in that one corner when it started to cut right here. So I've turned the air assist on, and I've bumped the blue where it had this bad logo up about 2% in power. So I'm gonna send this, and it's just as easy as that. So probably gonna have to set you down. Maybe. Let's see if I can do this one-handed. I've got to start this and then pause it so I can put that bar in. Okay. And we'll get my bar in. Focus height's a little high for the logo. Close the door and hit go. Okay, so you can see here now that we finished the logos, it kind of darts around, cutting out all the center sections. So now it'll go along, split everything vertically. Once that's done, it comes along, splits everything horizontally, and finally it does the perimeter. And you can watch that satisfying drop. So now we've got 2 garbage bags full of foam. This was enough for 24 laminators, so 3 sheets. So basically I stood there at the laser for about 45 minutes. So now what will happen is I'll take these bags home and I'll dump them out on my kitchen floor and I'll sort them into sets. So bang, right? I've got a box just like this that I've ripped the front out of, and I'll put them into the box in the correct order and glue them together. The glue has to sit for roughly a minute just to set up enough to where I can take it out of the box, put it in a good box, and then go from there. So while this glue sets, I sort through the pile on the floor and organize into sets. Now, if I were a smart man, which I've never claimed to be, I would have 5 garbage bags, because there's 5 pieces, and I would put them into their individual bags as I go. Haven't done that yet, but maybe in the future I'll get a little smarter, and that way it's already pre-organized when I get the stuff home, and I'm gluing the stuff together while I'm watching TV. The gluing is the longest part of this operation, of making this nice packaging foam for whoever buys the laminator. So to do, let's see, 99, to do 18 sets, the last time I took the stuff home and glued it together, it took me about 2.5 hours. So, whoa, Alexa just started talking. That's nuts. Weird. So anyway, this will take me about 3.5 hours to glue all these together, and we've only got 4 laminators left in stock. I've got 30 more on the way being made, and so this will get us going. I've got some already done at home, just waiting for parts. So anyway, that's that. I hope you guys enjoyed the laser video. Hopefully it was educational, and hopefully it was cool. On to the ATS-V talk. This dirty manifold came off an LF3 for like a CTS-V Sport. I bought this back several years ago just to see if it would fit on an LFX, and I had the idea to make intake manifold spacers for this, but I never really went through with it for some reason. I didn't know when you raise this, if the turbos, when they connect to the side of the manifold, the plenum where all the bricks are, if they would reach. Couldn't find anybody to test anything at the time, so it just kind of sat, and that was that. So last week I had a guy call me that wants us to make ATS-V intake manifold spacers. There's a couple companies out there that already make them, but they're pretty expensive. One company in particular, I can see why it's expensive, and the other company is just overpriced. So this guy calls me up and says, "Hey man, I really like you. I've always seen your LFX stuff. Think you're a great guy. Would you be interested in making these?" His ATS-V currently said he ran a 10.9 at 129, so that's kind of cool. But he wants us to make these spacers, and this just happens to be a prototype that I designed for the LFX back in 2013. So I said, "Yeah man, I think I already got you covered." It is a perfect fit on this manifold on one side, but when you flip it to the other side, the ports shift ever so slightly if you line it up with the bolt holes. While it would work, I want it to be better, and so if you flip it upside down to where the bolt holes don't line up, then the ports line up again. So essentially all I've got to do is take this design, modify it ever so slightly, make a left and a right, and that way everything's perfect. We'll send this guy a set. He's going to dyno him on his car. He's also going to be running the Texas Mile here at the end of the month, so that'll be interesting. But anyway, the LF3 and the LF4, there's essentially no runners in this intake manifold. And the other companies, their spacers are fairly thin, so they don't really increase the runner length. We're still going to do these. This isn't the exact material. This is just some random MDF that I cut out back in 2013 for a test fit. But we're going to do this out of the same 3/4 inch material and see what happens. And it's funny because we've tried multiple different engines at one point. LY7, the Pentastar, Dodge, and LFX, and every time we tried a different engine, we tried multiple different thicknesses, and every single time the 3/4 inch was the best. So I'm hoping that the 3/4 inch is the best in this application also, and we'll see what comes of it. But anyway, that's what we got going on right now. So I hope you enjoyed this video. That's all I got for today. Be sure to like and subscribe. Click that little bell for notifications for when I put new videos up, and be sure to check back. Thanks for watching.